are ready. Today's the 16th. All right, so here we go. Problem 1. I believe this is all no calculator, right? Mm-hmm. So let's see how we do with the no calculator stuff. All right, what's your idea for number 1? Who's got an idea? Someone please have an idea. What? All right, so one option, and remember, the beautiful thing about math is you can always do things more than one way, but one option is 7 to the x equals the 4 through to 49. You're not going to go wrong with that strategy, okay? That is fine. Now what, though? Remember, there's no calculator, so what, Katie?
49 can also be written 49 to 1/4.
Exactly. The 4 through, we don't like these radicals floating around, so we'll rewrite that as 49 to the 1/4. And then obviously in the no calculator section, everything's rigged. So you got a 7 and a 49, so 7 squared to the 1/4. So the answer is 2/4 or 1/2. All right, what about B? Divide by 5. The equation's not solvable with a 5 out in front of it. You have to get rid of that 5. And the easiest way to get rid of it is to just divide it out. Just get rid of it, period. And then, what? So we'll rewrite it as 7 to the second equals x minus 1. So 49 equals x minus 1 and x equals 50. At this point, we shouldn't be confused by that, right? 7 to the second equals x minus 1. That's how we translate a logarithm into an exponent. All right, what about C? What's the issue here? Yeah, somebody in this room will drop out all the logarithms and say 3x minus 6 equals 70. And of course, I'll get out my pen and draw a big X and say, ah, because you can't do that. You are allowed to drop the logarithms from both sides, but only when there's one here and one here. So the first thing you have to do is condense this into one logarithm. So when we put it together into one logarithm, it's going to go together as a division because of the subtraction. So it's going to be 3x over 6. Now you can drop these guys out, right? You can't drop them out until you have just one on each side. So now we can say 3x over 6 equals 70. So that's really x over 2 equals 70. So did you get 140 as your answer? I hope I did. I'm kind of checking these as I go. Oh, D is an easy one. Why is D easy? Whenever you have an ln and an e back to back, they cancel. So this cancels, so 2x equals 12 and x must equal 6. E is even easier. What's the answer to E? 10. It's a property. You don't even show any work. There's no work to show. It's 10. All right, what about F? What about this one? Yeah, we have the same issue we had before. You don't want two logarithms on one side. These have to be put together. together into one logarithm. So this time when I put these together, how will I put them together? As a multiplication. So 4x plus 20. Now this is a little different than that one was, because that one had logs on both sides. This one does not. So how do I deal with that when there's only one side of logarithms like this? 2 to the 4th equals 4x plus 20. So 16 equals 4x plus 20. So 4x equals negative 4 and x equals negative 1. Now, sometimes we get extraneous roots when we solve logarithmic equations. And sometimes when kids get negative numbers, they immediately disregard them. There's nothing wrong with that negative 1. Because when I put the negative 1 back into the problem, what does this equal? 4. And when I can take the log of 4. Now, if this had been x minus 5, then that would be an extraneous root. Because what would this equal? Negative 6, and you can't take the logarithm of a negative number. It isn't that x can't be negative. X can be negative. It's this that can't be negative. So when I plug my negative 1 back in, this is still positive, so that's fine. So negative 1 is the answer to the question. Okay, you understand that? Same thing if we had, if our equation were this. Whatever, okay? And we solved it and we got x equals 5. That would be an extraneous root. Because what happens when you put 5 back into the problem? You get a negative number here. You cannot take the logarithm of a negative number. Remember, the domain of your logarithm is bigger than 0. You gotta have, this has to be bigger than 0. And so just keep an eye on that when you're solving your logarithmic equation. They can have extraneous roots. This one does not. This one's fine. Okay, what about G? What are we gonna do, Patty?
I was gonna transpose it to x to the third equals 6.
I love that word transpose. That's a good word to use to describe that. You're exactly right. X to the third equals 6.
Yep, and then we gotta figure it out from there.
Yeah.
Cube
root both sides. We're going to cube root both sides. So the answer to the problem is just the cube root of 6. Yep, that is exactly the same as 6 to the 1/3. If you prefer to write it that way, it's perfectly okay. This is a no calculator section, so that's all you can do. And finally H.
Oh boy. It's looking scary.
Well, it does look scary, but you know what? It's not. If you think about it, it's not scary. Now, sometimes LNs and E's cancel, right? But in order for an LN and an E to cancel, they have to be back to back. I got a radical in the way. See how that's in the way? So let's get rid of the radical. Now, what happens to the LN and the E now? They cancel, so what's the answer to the question? 3/4. How easy is that? All right, 2A, write the equation of an exponential function. When I say write the equation of a line, y equals mx plus b pops into your head, or at least it should. What pops into your head when I say write the equation of an exponential? Y equals a times b to the x. That's what we're shooting for. Okay? So here we go. I have the point 0.03 and negative 275. Everybody's busily working. You don't need my help on this one. You know what to do, right? Gonna plug in the point with a 0. So A ends up equaling what? 3. Everybody good with that? Anything to the 0 power is 1. So now you've got an equation, you know what A is. So now we'll plug in that other point. Divide by 3 first. Now, some of you are going to go through this step by step. Some of you are going to look at that and say, oh, I know what B is. Doesn't matter. If you have to go through it step by step, that's perfectly okay. It would look like this, probably, if you did it step by step. And so what does B end up equaling? 1/5. So your equation, and don't forget to write the equation. That's what the question was. The equation is 3 times 1/5 to the x. And we never combine the 3 and the 1/5. It just stays just like that. I feel like we've done a million of those. You okay with those? All right, and then we've got a logistic function. Okay, so what are you thinking when I say logistic function? Yep. Now you need to know that. Obviously you can't come up with it if you don't know what you're shooting for. That's what your equation is going to look like. Okay, so look at all the given. Where do I start? I have a whole bunch of stuff given to me. Where am I going to start with all that?
Limit to growth.
Limit to growth. And what do I do with the limit to growth? It's A. I don't have to do any work. I just stick that in. So anybody that doesn't at least get partial credit on this problem deserves to be smacked. Because all you have to do is put in 60. Everything else is going to require some effort now, right? So where do we go from here? Initial value. You remember that the initial value is the y-intercept. So it's 0, comma, whatever the initial value is, 40. 0, comma, 40. So I'm going to plug that point in. 40 equals 60 over 1 plus bc to the 0. And just like with the exponential, the beauty of that is, what? That is gone. Because what's c to the 0th?
1.
1.
Anything to the 0th power is always 1, no exception.
No exceptions, you're right. Except, there is an exception. 0 to the 0th is undefined.
Alright.
Alright, so we have 40 plus 40b equals 60. I am cross multiplying and distributing. So 40b equals 20, and it looks like b equals 1/2. So we're getting closer. Now we have the b value. So y equals 60 over 1 plus 1/2 c to the x. That's where we are right now. But luckily, we still have one more point, don't we? 220. So put 20 in here. And 2 in there. You know what to do? Cross multiply, distribute again, just like we did in this last step. So 20 plus 10c squared equals 60. So 10c squared equals 40, and c squared equals 4. Which means c must equal 2. So our final answer that we write in the answer blank is y equals 60 over 1 plus 1/2 times 2 to the x. Are you going to cancel out the 1/2 and the 2? Never. They're two separate numbers. Leave them alone, even though you're tempted to do that. Okay? Now we're going to pencil a piece of paper, honey. This is a big review. This is a great review, if I do say so myself. All right, C. Write the equation of the asymptote of y equals 3 to the x plus 2. All right? What pops into my head? I don't have a calculator, so I'm going to have to rely on stuff I know. What do I know about things to the x power? They're called exponentials. And do I know what they look like in general? So I'm going to start with what I know an exponential looks like in general, which is this, right? That's a picture of y equals 3 to the x. This is a picture of anything bigger than 1 to the x. So 7 to the x, 15 to the x, root 12 to the x. This is a picture of anything bigger than 1 to the x power. It's a growth function. This is the point 0, 1, and this is the asymptote, which is the line y equals 0. Now, that we learned way back in like September. Okay. Now, we also learned way back in September what happens when you stick a plus 2 onto any function. What happens when you stick a plus 2 onto any function? It takes whatever it was and lifts it up 2. So that means the asymptote that was at y equals 0 is now where? Y equals 2. Write the equation of the asymptote. Y equals 2. Easy. Write the equation of the asymptote of this. All right, so what are you thinking when you look at this problem? Where are you starting? What are you starting with? What does a logarithm look like? What does just the basic old generic logarithm curve look like? It has an asymptote here at x equals 0, and it looks like this, right? Oh, Miss Ford, how do you expect me to remember that? I just do. You gotta remember it. That is the log of anything, okay? It can be ln, it can be log, it can be log base 7, it doesn't matter. This is what y equals log base something looks like. Now, what are we doing to it? We're subtracting 3 inside the parentheses. That's different than that, right? What does subtracting 3 inside the parentheses do? Moves it 3 units to the right. So everything, including the asymptote, gets picked up and moves 3 units to the right. So the asymptote that was at x equals 0 is now at x equals 3. Write the equation of the asymptote, x equals 3. Now along those same lines, we have, now we're going to sketch this. Domain, range, asymptotes, growth or decay. So a lot of different questions there to answer. A growth or decay, I think we can answer right now. Take a look at that equation. Would you say this is a growth equation or a decay equation? Decay. And we know that because the base here is a number less than 1. So this is going to be a decay equation, which means instead of looking like this, it's going to look like this. Now, on the test, I have asked you to actually plot some points. So let's approach that. Even though I already know basically what that's going to look like, let's plot some points. And let's just go with the easy ones. We want to keep the numbers relatively small. So when we say plot points, we mean set up a t-chart, pick some x's, plug them in, get the corresponding y's. So what happens if I let x be -2? 4, -1, 2, 0, 1, we know that for sure. Thanks, Patty. 1 gives us 1/2, and 2 gives us 1/4. So let's plot those and see if what happens is kind of what we assumed would happen. Is that what we thought would happen? Yep. So there's the picture, plotting points, there it is. Now, what are the other questions? What is the domain? Okay, so what's the domain of that function? All real numbers. So we can either say all real numbers, there's nothing wrong with that. If we want to look like mathematicians, we'll write it like this, right? That means all real numbers. What about our range? What's our range? The mathematical way of expressing the range would be 0 to infinity, and am I including the 0? No, because it is an asymptote. Basically, we want all the x's greater than 0. Patty?
Yes.
How about asymptotes? This equation have any asymptotes, or this picture have any asymptotes? Yep. What's its asymptote? Y equals 0, right? Okay, it looks like everything else now is a calculator, so get your calculator out. Want to make sure we can do it all. So we got this given. And we're going to do a couple of things. We're going to find the log of the cube root of 14. And we're going to find the log of 8x squared. All right, we talked about these the other day. What's our strategy? How do we even begin this problem? You can't, there's nothing just to type in yet. Eventually we're going to type in, but we got to do some stuff first. So start right here. What do we think about this? Yeah. Mrs. Ford has made a big deal about the fact that logarithms and radicals don't belong together. Okay? So we're going to rewrite that as 14 to the 1/3 power. And then we're gonna remember something very special about taking the logarithm of things to powers. What about that power right there? He'll come out in front. Now, did they give me, or do I have the log of 14? Was that given to me up there? No. But I can break 14 down, right? So if I break 14 down, I can think of it as 2 times 7. And if I want to pull that apart so that I have my separate logarithms, what am I going to do to them? Since the 2 and the 7 have been multiplied, when I pull it apart, it'll come apart as an addition. The log of 2 plus the log of 7. So the whole point of this exercise is to break this thing down into the given. Since 14 is 2 times 7, I can add the logarithms of 2 and 7 to get the logarithm of 14. And now I just plug in my numbers. So 1/3 0.012 plus 0.456. And my answer will work out to be 0.156. Okay, now we need to be able to do that on our own. So let's take a look at this one and let's see if you can do kind of the same stuff. Obviously it's a different problem, but we want to do basically the same things. Okay. So what's a thought you have? We can leave it blank, get no credit, or we can jump in and do something. So what's a thought you have? What? Now that's a great idea. Problem is it doesn't belong in the front because the 8 is not squared. If it had been this, then I would absolutely move the 2 out to the front. It is not. So the first thing I have to do is recognize I've got a multiplication going on there. So if I want to pull this apart, first I'm going to pull it apart as the log of 8 plus the log of x squared. In this case, the 1/3 went with this whole thing. There was only one thing, but it went with the whole thing, so it could come out in front. This 2 does not go with the whole thing, so it can't come out in front of the original problem. Now, what's this? Log base x of x squared. What's this? That's just 2. So that's done. I know I'm just going to have a plus 2 there. Mallory?
Log, or 8 could go to 2 to the 3rd.
Okay. So 8 you can think of as either 2 cubed, which is the most efficient way to think about it, or 2 times 2 times 2. If you think about it as 2 cubed, then what are you going to do with that 3? Bring it out in front. If you think about 8 as 2 times 2 times 2, then you would have the log of 2 plus the log of 2 plus the log of 2. That would be another way of doing it. And isn't that just a long version of what you said? Yeah, so it works either way. And of course the log of 2 they gave me, so I can plug that in now. So my answer will be 2.036. got? Evaluate the log base 15 of 16. So in other words, figure out what that equals. Why don't I just type it into my calculator? I have a calculator. Because it's base 15. Yeah, I can't do that. So what am I going to do? 15 to the x equals 16. So I'm going to get rid of the logarithm I can't deal with. I cannot deal with a base 15. So I get rid of it. Now, though, I got my variable up here as an exponent, so I'll need to take the logarithm of both sides, pull the exponent off, and x equals the log of 16 over the log of 15. The day we talked about this, I casually mentioned something called the change of base formula. I told you I don't use it, I don't have it memorized. If I found this problem in the hallway, this is exactly how I would do it every time. But notice, what did the answer end up being? It will always work out if you have, let's say, the log base 7 of 10, that we can go through all those steps, which is what Lisa Ford will do every time. Or you can remember that that will always equal the log of 10 over the log of 7. Always, always, always. So if you want to remember that and use that, it kind of eliminates all these steps. Answer will be the same, does not matter which way you do it. Okay, now we've got our word problems. Alright, so here we go. When I read a word problem, sometimes they give me a formula. So for example, in number 10, I see I'm given a formula, right? So if they give me the formula, then I'm all set. But if they don't give me the formula, like number 6, I have to figure out which one it is. And you have 4 choices. I did not put the book ones on here, so we'll have to get them out of our book. But there's the 2 that I'm going to give you, and there's the 2 that you have memorized. So we have to decide which one we're going to use in problem number 6. So what's your thought on problem number 6? This one right here. Compounded monthly is your clue. Compounded monthly. So what's going to go where? This is the formula I'm using, so what's going to go where? 3 equals 1. 1 plus, I don't know, r, right, over 12. That's it, exactly. Thank you, Anna. That's it, exactly. Now, she used 3 and 1. Could you use different numbers? Yep, doesn't matter as long as this is 3 times this. Step 1 is going to be to divide. So we're all going to end up with this equation right here. We're all going to end up with that, no matter what we started with, because the first step is going to be to divide. We are kind of programmed to take the logarithm of both sides, but you're not going to want to do that this time, because why? The exponent is not the variable, so you do not want to logarithm both sides. You want to 204th root both sides, don't you? So this is 1 plus r over 12. And I'm going to think of this as 3 to the 1 over 204. Which I can easily type into my calculator. Make sure the exponent's in parentheses. 1 divided by 204. So once you get that typed into your calculator, remember you're solving for r. So you're going to have to subtract 1 and times by 12. So the interest rate I came up with is about 6.48%. Next, another word problem, no formula given, so I'm on my own. Which one am I going to use? One from the book or one of my memorized? I'm going to use the same one again. So tell me what goes where. I'm using the same formula for number 7. So what? 9876 equals 654. 1 plus over 2D 4T. Yep, there's your unknown. How long will it take? That's T. We gonna need logarithms this time? Oh yes. Oh yes. Not yet though. What has to happen first? So 9876 divided by 654. As long as it's a finite decimal, you can go ahead and write it down. Otherwise, leave it as a fraction. Alright, so I've divided, I'm ready to go. Now what? Take the logarithm of both sides. And the reason you're doing that is not to make it harder. The reason you're doing that is so that you can do what over here? Pull that exponent off, drop that exponent out into coefficient position. And now how are we going to get t? We're going to divide by everything that's not t. So we're going to have the log of this fraction divided by 4 and the log of the decimal. Now, anytime there's more than one thing in the denominator, be sure that you are putting that in parentheses. You won't get the right answer if you don't. And I got about 47.55 years.
You didn't put it in.
Oops, I didn't.
No, I'm probably Betsy.
Okay. All right, number 8. What is the growth rate for a strain of bacteria that grows from this to this in 17.4 hours? Remember, this is the only formula that you can use if it's not money. All 4 formulas work with money. All 4 of them can be done with money. This is the only one that can be done without money. So, alright, so what goes where? We're using our PERT formula. So what goes where? 7654 e to the 17.4r. Here we go. Divide, always divide first. Now what? ln both sides. And this is particularly beautiful now because when you ln both sides, over here on the right, I have an ln and an e back to back, so this is just 17.4r. So my answer is going to be ln, that fraction, divided by 17.4. So I got about 13.24% growth rate. It says, what's the growth rate? 0.1324. All right, number 9. I borrowed from your car. The interest rate is this. You make monthly payments for 5 years. How much is each payment? If you put $3,000 down, how much will ultimately pay for the car in total? Okay. Did you read the question?
Yeah.
Did you see the keywords in there? Payment? So what does that mean?
P word.
We're either going with FV or PV. Since we are paying off an existing loan, PV. We're not saving for the future. We're paying off a present value of a loan. So the formula, which I don't have written down, but I'm going to go ahead and right here. Okay, so here's my formula, and those will be provided. You'll have to decide if it's FV or PV. In this case, it's a PV, because we're paying off an existing loan. Okay, so now what goes where? Uh-oh. What's the present value of the loan, people?
12,500.
So 12,500. What's my interest rate? The interest rate, you gotta be careful in these formulas. You don't just put in 0.0895. What do we have to put in? Divided by 12. So we have to put in 0.0895 divided by 12. What power are we raising that to? The 60th, actually, yes, and it is negative. And why is it 60? Because we are making monthly payments for 5 years. Now, to get R, don't I just need to divide 12.5 by that thing? Right? So I just need to get that typed in my calculator and then divide that number by it. So again, when I type this into my calculator, I type in the numerator exactly the way I wrote it. 1 minus parentheses, 1 plus 0.0895, close divided by 12, close parentheses, raised to the negative 60th. So what did you get when you typed in that numerator? 0.359? Now, what do you need to do to that? You need to divide it by the denominator, but there's 2 numbers down here, so make sure you got parentheses, divided by 0.0895 divided by 12. Now what do you have? 48. So this die equals 48. So we're gonna take 12,500 and divide by second answer. And how much are those payments? $259.18. Okay? So how much are the monthly payments to pay off this car loan in 5 years? You're gonna pay this much every month. Now, if you put down $3,000, how much will you ultimately pay for the car in total? No, how much will you pay altogether? You've already paid $3,000,
9,500.
and now you're gonna pay $259,018. How many times? 60 times. So 259.18 times 60. That's my payments plus the original 3,000 I paid. So altogether, this car is going to cost me $18,550.80. That's how much I'm going to pay for it. It originally cost $15,500, right? Because I borrowed this much and paid $3,000 down. So basically, I paid an extra $3,000 in interest.
I just left it in my calculator. Would you accept?
No, because you're going to make a payment every month, and so you have to have a payment amount, and then that times 60 is what you want. Okay, one more. This one I have a formula for, so I don't have to worry about it. I got ants in a colony. All right, here we go. 4 questions. How many ants are present initially? And if anybody in this room says 500, I'm going to pop you. How many are present initially? What does that mean? That means 0, comma. This is the initial value. So if I want to know how many, what the y is initially, I'm going to have to put in 0 for x or t. So I'm going to put in 0. And I basically have e cubed then down there. I'm putting in 0. So 500 divided by, now, you got more than one thing in the denominator, make sure it's in parentheses. 1 plus, how do we get e on our calculator? Second ln, and it's 3. I have about 24. I wouldn't argue with 23 if you said 23. I got 23.7. I rounded up. If you want to say no, there's only 23. I'm not going to argue with you. About 24 ants. Would you agree with that? How many ants are present after 4 days? Plug in 4, do exactly the same thing, but plug in 4. The initial value is after 0 days, right? That's why we plug in 0. If we want to know after 4 days, we're just going to plug in 4, which will give me e to the negative first. So again, make sure you got your denominator in parentheses. I got about 366 ants. Again, I'm not going to argue with you if you say 365. After how many days will there be 342 ants? After how many days will there be 342 ants? What do I do? Put that in here. put 342 right here. So 342 equals 500 over 1 plus e to the 3 minus t. We're solving for t after how many days? It's a little tougher to solve. What do? Multiply? Distribute? So 342 plus 342 e to the 3 minus t equals 500. Now what? Subtract 342. Oh, I should be able to do that. Is that 158?
Yeah.
And then divide. Now I know that fraction reduces. If you want to go ahead and reduce it, you can. But I mean, we're nowhere. I mean, that's not the answer, so I'm not going to worry about it. What am I going to do now? ln both sides. And of course, that's going to give me an ln and an e back to back. So 3 minus t equals ln the fraction. Now your job is solving for t. So let's rearrange things a little bit. If we rearrange things, t will be 3 minus ln 158 over 342. I just do a little rearranging there. So 3 minus ln 158 divided by 342. I got about 3.7 days or hours. I can't remember days, years. What's the days? So 3.77 days. And then D, one more question. What is the maximum number of ants that the colony can support? That one is the one you can say 500 because that's the limit to growth. If we graphed it, that would be the top asymptote of the logistic function. Okay? Now, we just went through the test except for one problem. There's one problem on the test that's not on that sheet, but it's on the other worksheets. So you'll figure that out as you go through. But that basically is the test. Okay? Okay? So, let's stand up, stretch, take a deep breath, and then we're going to do whatever problems you need to do to review. All right? We just took the test. Pretty much. Almost exactly. So we know exactly what Mrs. Ford expects out of us.
Let's see what?
Okay.
Fights. Can we move all the desks?
No. All right, back to focus now. So, I am going to put you on the spot now. Of all the problems that we just did, that was the test, right? So, when you sit down with this paper in front of you that looks just like that one, except the answers won't be there, where are you going to falter? Where are you going to struggle? So tell me what problem that will be. All right, Mallory, I'm going to call on you, but I expect you to start coming to class on time.
Okay.
All right. Which problem? Give me like a number. Like what number on there? What kind of problem?
2A.
Like 2A? Write an exponential function?
I always get confused when they give us 2 points, so I don't know what to do.
Okay.
Jeez.
So we're gonna write an exponential function, and our 2 points are this. These are our 2 points. Okay, so she says she has trouble writing an exponential function. Well, what's the very first thing she has to know? Y equals A times B to the X. All right, now she gets confused because she's given 2 points. What is our standard rule of thumb? Use the one with the 0. Remember, this is X and this is Y. Plug that in. So 3 equals A times B to the 0. And as Patty so eloquently told us earlier, anything to the 0 power is 1. So that's like ignored. So A is 3. So without much effort, I now know that Y equals 3B to the X because A is 3. Now I'll go back and take my other point, which is another X and Y, and I will plug it in. So 3/16 equals 3B to the negative second. To solve that, divide by 3, since it's a fraction, maybe multiply by 1/3. So 1/16 equals B to the negative second. Some of you know what B is going to be from that. You can tell me what B is. If you can't, that's fine. I'm going to write it like this. Cross multiply. Oops, cross multiply. And B equals 4. So our answer is Y equals 3 times 4 to the X. And you're not going to do this. That is so wrong, I'm even going to erase it. The 3 and the 4 cannot be combined ever. The answer is 3 times 4 to the X. All right, Mallory, does that make sense?
Yes.
Okay, who else? Where are you going to struggle, Jared?
We do one like 4.
4. So let's say the log of 3 is 0.12, and the log of 5 is 0.34, and we're going to find the log of, let's say, 25 thirds x. All right, so where do we start? Where do we start? You gotta break it apart. You have to break it apart. So one option, and this could be done in one step or more than one step, but one option, this is the log of 25x minus the log of 3. Would you agree with that? Because you have a division problem, right? So when you start to pull it apart, and kids, you have to pull it apart because these are the givens. Somehow you gotta be using these numbers, which means you gotta have 3's and 5's, not 25x over 3. You have to break that apart. So now, this one we know, that is going to be 0.12. But this one we're not ready yet. This has to go down farther, be broken apart more. So how could that be broken apart? The log of 25 plus the log of x. These are multiplied so they can come apart as an addition, right? Now, what's the log base x of x? So it's 1. Now this one I'm still not ready for. This one's still not broken down far enough. So what am I going to do with 25? 5 to the second, or 5 times 5, whichever, you like best. So if you think of it as 5 to the second, then what happens to the 2? It comes out in front. So now I have 2 log 5's plus 1 minus 0.12. Now can I do it? Yeah, because log 5 is 0.34, so this is going to be 2 times 0.34 plus 1 minus 0.12. And then just multiply all that out and get the answers. Okay, Jared? All right, who else? Bessie?
Are problems like the one in the 3.5 and 3.6 video that we watched? You're gonna be on there, like I don't know, like the one.
The ones that are in quadratic form?
Like e
I
to
don't
the
know,
x
like
plus e to the negative
Yeah,
x.
no. No, Bessie, I just said, what's the test look like?
Well, you said, but then there's also one other thing that's.
But it's on the other review sheets. Have you seen any of those on any of the other review sheets? No. No. It's okay to check. It's good. I'm glad you watched the video. God bless you. All right. So what are the rest of you who else is gonna struggle with something? Because if your hands are up right now, I'm expecting a perfect paper, a totally 100% perfect paper.
Number 9, like the 3,000, yeah, I got confused.
That just means you already paid $3,000. That doesn't have anything to do with the formula. It's when you buy a car, you normally, or a house. Yeah, so when it says how much did you pay altogether for the car, you have to include what you initially put down. So it doesn't have anything to do with the formula or anything. You add $3,000 to what you paid in payments, because that was your initial payment.
Are there gonna be any half-life problems?
And what would bother you about a half-life problem?
I don't know, just 'cause it's harder than that.
Okay, so let's suppose we have to find the half-life of something, if 18 grams decomposes to 15 grams in 18 days, let's use a different number, in 25 days. Alright, so what are we going to do? If this problem pops up, find the half-life if 18 grams decomposes to 15 grams in 25 days. Well, first of all, there's no formula given. So you're on your own. So it's either the ones in the book or the ones you have memorized. Which one is it? It's PERT. If it's not money, it's going to be PERT for us at this point in our lives. If it's not money, it's going to be PERT. All right, so what can I put in where? 15 is what I end with, 18 is what I start with, and I'm waiting 25 days. Now that makes perfectly good sense. The problem is it doesn't answer the question. What is this going to give me? What's that going to give me? The decay constant, right? It's going to say like 12% or something, actually negative 12%, right? It's going to give me a decay constant. I need the half-life. Well, wait a minute. If I need half-life, then I really don't want to end up with 15 grams. I want to end up with how many? 9. So that would look like this, and this is your half-life right there. The problem is that equation's not solvable. Too many variables. So I need this one, because then I can plug it in here and I can get what I need. This is not the answer, but I need it. So I better figure this out. So how do I do that? Divide by 18. So I'll go ahead and say 5, 6, but you can say 15, 18, so it really makes absolutely no difference. And then what? ln both sides. And of course, when I ln, I'm going to have just 25r on this side. So ln 5/6 over 25 will be my growth constant or decay constant.
You're not cute. So funny.
So I got negative 0.007. But that isn't the answer, remember. That just tells me how fast I'm decaying. I want to know the half-life. So now I'm going to solve this equation. So what do I do? Oh, not yet. Divide by 18. And then what? ln both sides. So ln 0.5 equals RT, and T equals ln 0.5 over R. So I'll just take ln 0.5 and divide it by my answer. Oh my, how long is it going to take? 95.04 days.
I think we're ready.
Yeah.
We should take it now.
You can take it now.
All right, one more
You
question.
just signed us a death warrant.
Can't leave, so we do one more question.
Oh my god. Let's do number A.
Peyton has her hand up.
Can we do like a
1A.
number 3? Can we do like a no, just
Oh
kidding.
my god.
Not number 3. C, can we do like a harder?
Which C? There's 2 C's.
2C, sorry.
There's 3 C's.
2C, find the equation of the asymptote. Alright, so we want to find the equation of the asymptote.
No, C's the
Make it really hard.
3 to the x plus 2 opposite asymptotes.
Yeah, there we go.
Y equals -1.
Alright, so we're going to go through these. One is a logarithm and one is an exponential. And we're finding the equation of the asymptote. Right?
Yep.
So the first thing, I'll do this one first. The first thing I think about is, okay, what does a logarithmic picture look like? This is a logarithm. What does it look like? So I either draw it on my paper or I hold it in my head. This is the picture. And I am interested in this problem in the asymptote. So here is the asymptote. And it has an equation, x equals 0. So that's kind of the baseline. Now, what am I doing in this picture? What am I doing here? I'm moving it left 2. Okay, so this asymptote is now coming over here, right? Left 2. And then I'm going, now, this asymptote is vertical. Dropping it down doesn't do anything, right? Not to a vertical asymptote, that doesn't make sense. So the answer to this question is your asymptote is at x equals -2. Now, this one is an exponential, so I'm starting with a different baseline picture, starting with this. And that asymptote is initially at y equals 0. It's a horizontal asymptote at y equals 0. All right, so what is that doing? Taking it right 3, but wait a minute, it's a horizontal asymptote. Moving it right 3 doesn't change it, right? What does that do? Up 1, now that will take this guy and move him up 1, so now he's at y equals 1.
Isn't the top one at 1, 0? So then you went over 2. Oh.
We want to talk about the asymptote.
Okay.
The asymptote. Only the asymptote.
Yeah. Only the asymptote.
Only the asymptote. All right. Now, I would suggest, here's what's going to happen. You have one more class, right? Or do you have 2 more? One more? All right. So here's what's going to happen next tomorrow. Here's what's going to happen tomorrow. You're going to come in with questions from the review sheets, or we're starting chapter 4, all right? Because I have reviewed, I've gone through every possible problem I can think of, so now it's up to you. I'll answer your questions, or we start chapter 4, because I can't wait.
Me neither.
No, it doesn't matter, this is a no phone zone.